Hi, my name is Juan Guerrero, and today I'm going to be talking about logic gates. I'm going to be building 3 separate logic gates with this breadboard. The first one would be the AND gates on the breadboard. To do this, I would require 2 wires, one for my 5 volts, one for my ground. I will also use 2 separate wires as my switches. I will also be using these transistors. From left to right, it's 1, 2, 3. The first being the emitter, the second being the base, and the third being the collector. It will require 1 LED light. It will also require 1 resistor, and of course my Arduino kit, my connection to the battery, and the battery itself. So first, to start the breadboard off, I'm going to make this red line my live, which will be 5 volts. This will be my active, and it will be in the color green. And I will be making the white my ground. And then when the battery is connected, the live line will be right here against the red, and the ground will be against the blue. I will start off by connecting my resistor from the live red to a line right here. Now to go through and disconnect it right there. Now for the transistor, right here the collector will be connected to the same line as the resistor. The base will be in a separate line, as well would be the emitter. So we're going to put it, as I said, separate with the flat part facing out, so you can see all 3 lines. We will be also setting next to it with this time with the collector on the same line as the emitter. We'll be putting it right here. Perfect. Next, I will be connecting my LED light. I will be putting it on the last line, the same as the emitter on the final transistor, and the short leg will be connected to the ground, as the live leg is for the live, for the long leg is for the live wire. So I'm gonna straighten this out. Here you are. And then just to show you, I will be connecting the 5-volt battery to the connection, and I will be connecting the green wire, which is my live, to my 5 volts. And I will be connecting my white, which is my ground. And I will connect the battery to the Arduino chip. As you can see, the light is on, but the LED light is not on. This is because the circuit is incomplete. So to complete it, these 2 wires, the red and the blue, will act as our switches. So for the blue, one will go on the first leg, which is the collector, and the resistor, and then it will connect to the second leg. And if you can test it out again, once again light is on, so there is power, but as you can see the switch is still off. This, with the AND gate, both switches must be on and connected for the LED light to turn on. So once again, we remove this, connect one part to the collector, and the second part will be to the second leg. Make sure everything's fitted, and finally the LED light is on. To get you a better view of what is happening here, So the way with the transitions, this would allow us, for example, to do motion sensor and room temperature sensors. So as discussed in class, with this one, this switch, it can be used as an example as a motion sensor. Let's say the switch is for an air conditioning unit, which is motion sensor activated and temperature activated. So for the sensor to work, the temperature, the room must be higher than a certain temperature for it to turn on. And if it is not, and the switch does not complete, the system will not run correctly. If however there is no motion sensor in the room as well as the temperature required, there will still be no power. So for an AND gate to run with both transistors, both switches must be connected and on for the LED light to be running. The second gate that will be showing you is the OR gate. It works similarly to the AND gate, but has a few different pieces. And it will require a different situation for the switches to function correctly. So you're going to need the same transistors. Again, right to left, 1, 2, 3. This one being the this one being the emitter. Second, the base, and the third, the collector. I'm going to go ahead and set the transistors up first, as the circuit will depend on the placement of these two. So there's my first one. I will do my second one, and the next one over. So they are not in the same line, but are near each other. And of course my green will be my live, as was the last one. It will be connected to the red. That will be where the 5 volts of energy goes. And the white will be my ground. And then I will be using this resistor as well. And I will be connecting it to the ground and the same line as the collector. And you have it as shown. Now for this one, first I will be connecting the collector and the base. So there's a wire in the same line. I will also be connecting another line from the same line, which is the collector of the original, to the collector of the second transistor. From here, I will be connecting again the collector to the second prong, which is the base, as shown. And I lastly will be connecting from the emitter of the original to a separate line, which would have our LED light, and the short leg will be the ground, and the long leg the live, connected. And then this one will be from the emitter of the second to the LED light. So as before, I will be connecting my green to my 5 volts and my white to my ground. I will be connecting my battery to the plug, and I will be plugging it in. And as you can see, it runs similarly to the AND gate. The power flows through both transistors and lights up the LED. So while the OR gate is similar in structure to the AND gate, the major differences would be the 2 switches. While the AND gate also has 2 switches, the OR gate does not require the 2 switches for power to be going through the entire circuit to the LED light. So for example, these 2 blue wires which connect to both of the transistors separately, do not need to be connected at the exact same time for the LED light to function. For example, if I unplug this blue line, this switch, this line is not on, and this line is deactivated. So there's no current flowing to this transistor. However, the LED light is still on. Just as well with this second switch, which is connected to the first transistor. If it is removed, the LED light turns off. So these are our two switches. Unlike the AND gate, as you can see, if I plug this one in, the LED light functions. Vice versa, if I plug in the other to the base, it also turns on. So as shown, both switches work to provide power to the LED, but both switches are not required to be on at the exact same moment for the LED to function. An example of this system would be an iPhone, where the password protection has 2 fingerprints of 2 different individuals. This allows one of the individuals to use the iPhone by inputting his fingerprint without the other having to do the same as well. And when neither is put of those two, it does not function. But when the other fingerprint is inputted as well, it works just as fine as the original. And there are many different applications for this, though it is at times less secure than the AND gate. Now I'm going to move on to show you the last gate, which is the NOT gate. So for the last gate I will be showing you the NOT gate. This works similarly, of course, to the AND and the OR gate. However, it has a little bit less wires and only one transistor. So to start off, I will be putting the single transistor first to make it easier. Again, right to left, it would be emitter, the third wire, the base, the second, and the collector, the third. So I will be connecting it right here in separate areas. So it is connected. I of course will be using my green as my live wire, which carry the 5 volts on the red line. And we'll be using my white as the ground, which will be on the blue line. So of course I'm going to put the LED first this time. I will be connecting the shorter leg to the ground and the longer leg to what would be the live section. This time the live section will be on the first leg of the transistor. Next I will be putting the resistor on. Of course it does not matter which leg you use. And I will be connecting it to the same line as the LED light and the transistor. I would have it connected as such. Finally, I will be connecting this blue line from the emitter to the ground, and this orange line will be connected to the collector and the base. Once it is finished, it should look as such. I will be connecting my green to my 5 volts. And my white to my ground. Reconnecting my battery and plugging it in. As you can see right now, the circuit is not running through to the LED light. However, when I remove this orange line, the LED light turns on. So, to explain a little bit more on why this is happening, the 5 volts is coming through and going from the transistor to the collector, the jumper line, and the LED volt. However, when the jumper line is connected, the energy goes from the LED instead into the base of the transistor. From there, the transistor line is connected to this blue, which is then connected to the ground, and energy will travel the path of least resistance and go through to the ground. However, when you remove the orange wire, the connection is broken as your base acts as the switch on the transistor and the LED light is powered on. Similar application of this would be solar power lights that turn on when the sun goes down. So for example, the street light is off during the day, so when the sun is out there is no street light on. However, when the sun goes down, the street light comes on. And it can be the same as the facial recognition on your iPhone. When the iPhone does not see your face, it will not open and the line will remain closed. However, when the correct face is recognized, the circuit will be open. And that concludes all three of the logic gates, this being the final NOT gate, and I have gone over the OR and the AND gate. Thank you very much.